Okay, so again, we have a function. It's a algebraic plus logarithmic two factors, and x has to be more than p and all real numbers. The first question is about finding the value of p. So since we have a natural log here, that's the guy that can restrain the domain a little bit because the natural log itself, ln of x, has a vertical asymptote at x equals 0. So natural log of x plus 3, the factor we have in our function, would have a vertical asymptote at x equals negative 3 because x plus 3 in a function means you're moving it to the left by 3 units. So this is what ln of x plus 3 looks like, which means that x has to be more than minus 3 for this guy to exist in the first place, right? So that tells us that p must be negative 3. Does that make sense?
Yeah.
So x has to be more than negative 3, therefore p is negative 3. Okay, that's done. Now, part B says find an expression for the derivative. This is not that tough. It's just basic product rule. So our function, let's write it down, 2x minus 6 times natural log of x plus 3. Like, for example, we can call this u and we can call this guy v, which means we have u prime v plus v prime u. That's the derivative. So what is u prime going to be? The derivative of this guy?
Um, 2.
Yeah. And what's v prime going to be?
1 over x plus 3.
Exactly. Times 1 technically because you need to multiply by the derivative of the inside, but that doesn't matter. So the derivative, therefore, is u prime times v plus v prime times u.
Mm-hmm.
There you go. So we can combine this into one fraction, make it look a bit better. There. So now we have the derivative. I feel like this question is about to pick up pace very quickly because it says hard over here.
Yeah.
So now,
One quick question.
mhm.
Why like p minus 3, we only take this part,
um,
find p?
because 2x minus 6 has no restrictions. You can put any value of x in 2x minus 6. It's natural log of x plus
Um,
3 that has restrictions. Natural log of x plus 3 cannot take any values of x less than negative 3, or less than or equal to negative 3 even, because ln cannot take an input of 0 or negative
yeah.
numbers,
Yeah.
right?
Okay, I
That's
get
why.
it now.
So
Yeah,
you
yeah.
have to kind of look at the problematic part of your function. So normally the problematic part would be the inside of a square root, inside of a log, the denominator, etc. Because the inside of a square root has to be positive or 0.
Yeah,
Then,
yeah.
yeah, the inside of a natural log has to be positive and the denominator cannot be 0. So these are the only three things you need to really look at in case of checking for domain, basically. This is, by the way, very useful information. So now let's erase this for now. Okay, so it's given that this function has no points of inflection. What does that mean? It means that there are no points such that the second derivative is 0.
Mm-hmm.
So there are no points where the second derivative equals 0, because inflection points are points where the second derivative is 0. Determine if the graph of y equals f of x is always concave down or concave up. Concave down means second derivative is negative, concave up means second derivative is positive. So we need to find the second derivative and check if the second derivative is always positive or always negative, etc.
Okay.
So for part C, we need to derive this guy again. So it has two parts. The first part is kind of easy to derive. This guy is just going to be 2 times 1 over x plus 3.
Well, yeah.
That's it. For this guy, we're going to use quotient rule. So let's call this u and let's call this v. So we're going to do u prime, which is 2, times v minus v prime, which is 1, times u, which is 2x minus 6. All of this is divided by v squared. Is this clear?
Mm-hmm. Yes.
Nice. So we have 2 over x plus 3 plus 2 times x plus 3 minus 2x minus 6. All of this divided by x plus 3 whole squared. So I'm not sure yet if it's useful or not, but mm, okay, it's not. So now, since we know that the domain is x is more than negative 3, we're trying to check the sign of this guy for all values x being more than negative 3. Okay, so let's break it down. This is a very important thing I'm about to do. It's called like sign analysis. I mean, it's basically I'm checking for the signs of each factor, each component basically. So remember that x is only allowed to be more than negative 3, okay? So
Mm-hmm.
if x is more than negative 3, this is always positive. This is anyways always positive because it's whole squared. Whole squared things are never negative no matter what happens. This is always positive. What about this guy though? If x is more than negative 3, then what's going to happen here? So for example, so what's the lowest value? X could be negative 2.999999. I mean, basically, x could be negative 3, which is not exactly true because x can't really be negative 3. But let's just, say that it's so close to negative 3 that it's essentially negative 3. What would happen in that case? 2x would be almost negative 6, right? And therefore, negative 6 would make it negative 12. And since this would be negative 12, this whole thing would be positive 12, right?
Yeah.
Which means that you're going to be adding positive 12, which means that for the worst case scenario, you would still get a case where, oh no, never mind. Hmm, okay, wait, I have an idea. Let's take this guy and factor out a 2. So if I take a 2 out, this is what I have. Okay, so, okay. So it looks like there's a boundary point. So, hmm, okay, here's what I'll do. I'm trying to see the sign of this for all different values of x more than negative 3, right? So let's think about the sign of this for different, like, okay, so this is called, what's it called? The checking the boundary points, basically. So I'm going to look at that numerator, okay? And I'm going to check when it
Can we just
equals,
like substitute one
yeah,
and
so
we'll see?
that's the problem. So if I'll have to substitute a lot of values for that, like for that to work, right? I'll have to check like basically an infinite number of values. Instead, what you can do is you can check the boundary point. When is this guy 0? Okay, here's what happens. So to check when this guy is 0, oh, whoa, 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 whoa. I just realized. Okay, okay, this is easier than I thought. You can expand this and something very funny happens. The two x's cancel out and just give you 12, which means this is all going to be equal to 12 all the time because the two x's cancel out. So
Oh,
yeah, I should have simplified this first. So if I simplify this whole thing, it becomes much simpler to work with. I end up with this, okay, which tells me that if x is more than negative 3, x plus 3 is always positive, and x plus 3 whole squared is also always positive, which means that this whole thing is always positive. You agree?
yeah. So it's like
Yeah,
going up.
which means that it is concave up all the time over all domain. There you go. So it was easy.
So it's going up all the time, basically.
No, no, no. That's not what concave up means. Concave up means it's curving upwards. This whole curve is concave up because like think about it like this. Where is it trying to go? It's trying to go up, isn't it? All the time. It's trying to bend upwards as opposed to this guy. See? This guy, even though he's going up, he's trying to go down. Like he's
Okay.
curling downwards. It's more of a curl situation. Okay? Concave up means it's curling upward. It's trying to increase its slope. Okay?
Okay.
Always,
And if it's on minus, then it's like going
it's curling downwards. So for
okay.
example, this is concave down. Even though it's going
Yeah,
up,
but
it's
if
concave
it's
down.
if it's like a parabola, then it would have like point of inflection, no?
No.
No?
Point of
Okay.
inflection means that the curl stops for some time. For example, look at this case. You see this line? It's going straight for a while. It's
No.
it's concave down, it's curling downwards, and then it just suddenly stops curling, and then starts curling upwards. It's always going up, but this part is concave down, this part is
Yeah,
concave
okay.
up,
I
and
see,
this
I see.
part is inflection. Okay? So yeah, you don't have to be going up to be concave up. You can all like for example, this guy is concave up, even though he's always going down because he's trying to go up. He's curling upwards. See?
I see, I see.
Yeah. So in a more like mathematical sense, concave up means you're always increasing your slope. Your slope is increasing in size towards positive side. So you can still like for example, if someone's slope is -10 and then it's -8 and then -6, -4, so he's going down sharply and then less sharply and then less sharply and then less sharply. But he's always going down. But he's still increasing his slope. He's going upwards. Like his slope is increasing towards the positive side. So he is concave up. You see
Yeah.
what I mean?
Mm-hmm.
So anyways, this guy is concave up therefore, always. Now we have a second function. Oh God, this looks fun. The second function is another logarithmic function. This time we have g of x equals 3 times natural log of 1 over x plus 3. And, oh, plus x. Okay, I didn't see that. There's a little plus x here. And the domain is again that x has to be more than -3, which makes sense because if x is less than -3, we're going to have a negative number in the input, which
Yeah.
doesn't work. So let's start with the derivative. So for the derivative, we're going to want to use chain rule for this guy. First of all, 1 over 1 over x plus 3, right? Because 1 over the inside, and then multiplied by the derivative of the inside, right?
Which is like, yeah.
Yeah, so that's now since 1 over x plus 3 is simply x plus 3 to the power of -1, we can say the derivative is going to be this. So that's the derivative of the natural log part. What do you think? So 1 over the inside times the derivative of the inside.
That makes sense.
Yeah. Plus the x just becomes 1. So let's clean this up. First things first, if you need help understanding how to simplify this, remember that if you have a over b divided by c over d, you can simply think of it as a over b divided by c over d, which means the same thing as a over b times d over c. Because you can, yeah. So the very bottom multiplies with the very top, and the middle two things multiply together, see? So that's the shortcut I used. So the top one, you can write it as a fraction to make life easier. And now you can combine the very top with the very bottom, and you will get this. See? The very top one with the very
Yes.
bottom x plus 3.
Yeah, yeah, yeah.
So you have this, and then of course you also have this guy to worry about. So I'm gonna put the negative up front, and I'm gonna put the x plus 3 to the power of -2 over here. If you want to be a bit quicker, then you can put the x plus 3 to the power of -2 down here as a power of 2 directly. Because, you know, -2 means denominator with the second power. Plus 1. Is this clear?
Yes.
Okay. Simplify, we got 3 over x plus 3. Because one of these is going to cancel out one of those. And you end up with this. That is your derivative. So simplifications are super important for paper 3 questions. It's definitely paper 3. Now, find the horizontal and vertical asymptotes of not g, but g prime. So we're trying to find the derivative, we're trying to find the asymptotes of this guy. Okay? First things first. For horizontal asymptote, no, for vertical asymptote, sorry, simply look at where the denominator equals 0. Okay?
Yeah.
So that's going to be when x plus 3 is 0, which means when x is equal to -3. So we found the vertical asymptote of the derivative. For the horizontal asymptote, you need to first make it one complete fraction. Okay?
Mm-hmm.
So I'm going to multiply the 1 with x plus 3 and make the whole denominator x plus 3 then, which leaves me with just x over x plus 3. That's my derivative, like cleaned up. Now, I don't know if you know the rules, but for a horizontal asymptote, there's 3 cases. Important to remember. For a horizontal asymptote, there's 3 cases. Number 1, do you know what the degree of a polynomial means, by the way?
Uh, I mean,
Degree means like the highest power of
probably.
x. So degree means highest power of x in the polynomial, basically. So for example, the degree of this polynomial is 1. The degree of this polynomial is 1 because the largest power of x available is 1. Now, if the degree of the numerator is equal to the degree of the denominator, meaning they're both quadratics or they're both cubics or they're both linear, whatever, then the horizontal asymptote will simply be y equals leading coefficient in the numerator divided by leading coefficient in the denominator. That's the first case. The second case is if the degree of the numerator is more than the degree of the denominator, meaning the top is a cube and the bottom is a linear, or the top is a quadratic and the bottom is a linear. If the top is heavier, basically, right?
Mhm.
For example, x cubed plus 2x over x squared plus 4. This is the top is heavy. What happens in this case is there is no horizontal asymptote. No horizontal asymptote. So the graph just goes up to infinity or down to minus infinity. It never stabilizes anywhere. Okay?
You can leave the picture actually.
Yeah, that's better. So in this case, for example, y equals 2 means that the graph will stabilize at y equals 2. Maybe from up here or maybe from down here. Okay? That's what this means.
Yeah.
And finally, the last case would be degree of the numerator is less than the degree of the denominator. So basically, the bottom is heavier than the top. So for example, like, x plus 5 over 2x squared plus 4x minus 3. The bottom is a quadratic, the top is a linear. In this case, the asymptote is always going to be at y equals 0. No questions asked. So
No
the
question.
graph will always stabilize at this value. Okay? Of course, I
Mhm.
mean, or they're not both of them. You don't know which one, but one of them. So these are the three cases. Now in this case, we clearly have, which case do we have? What do you think?
The first one.
Yeah, the degrees are equal. So the leading coefficients are 1 and 1, which means that the horizontal coefficient will just be at 1 over 1, which means just 1. Because,
Yeah.
yeah. So that's your horizontal asymptote, and you're basically done with this question. Now, find the exact value of the minimum of the function itself. So we need to, what part is this? Part F. So finding the minimum of g of x means that we need to find out where the derivative hits 0,
0,
right?
yeah.
So the derivative is x over x plus 3, which means that the derivative hits 0 when x is 0, right? However, there's a problem. If you go back, you will remember, okay, never mind, it's not a problem. It says that x has to be more than negative 3 and a 0 is more than negative 3, so it works. So the minimum happens here.
No, wait. No, I think that it was here, like, no, minus 3 over,
Hmm?
it's like this part, no?
I don't know where you are.
Like here,
Oh no,
here.
but the thing is, when I simplified the derivative, I wrote it like this. It's the
Ah,
same
you
thing.
wrote it like that, okay.
Yeah.
My
I'm going to
bad.
use the simplified version. It's easier to work with. But
Okay.
regardless, this is this is where the derivative happens. And to find the actual minimum value, I need to plug it into the actual function itself,
So like
which is
3.
going to be 3 natural log of 1 over 0 plus 3 plus 3. Which is going to be, okay, let's try to figure this out. Okay, so 3 natural log of 1 over 3, we can't really do much there, and then plus 3, and that's it. That's the minimum possible value of my function. And please don't tell me to sketch it. Okay, thank God. Solve,
No,
yeah,
I think they asked like no, okay, never
yeah.
mind.
So now we need to solve this inequality where f of x is less than g of x. So let's pull this down here and
In sketch,
do,
we have the horizontal, no, the
yeah,
vertical.
but left,
We have
like,
to
it's gonna
find
be
the
a
x.
pretty tough sketch to figure out. So f of x looks like this. And g of x looks like this. We need to figure out f of x being less than g of x. Oh god, that does not look fun. Okay. Wow. Ooh, okay, I see the trick. Okay. Sometimes I impress myself. So 1 over x plus 3 can be written down as x plus 3 to the power of negative 1. Do you agree?
Wait, can we go back to like the previous exercise? Because there's like
Oh
find the
yeah.
exact value of minimum of y equals g of x. And you said the g of x is like 0. No, the
No.
derivative.
No, the derivative is gonna be so whenever someone asks you to find the minimum of a function, you have to find out where its derivative hits 0.
Mm-hmm.
Where? At what x value? So what I did was, okay, you want me to find the minimum of g of x? Okay, let me check when the derivative of g of x hits 0. I found out it hits 0 at x equals 0. So I said, okay, that's where the main function is going to be at its minimum possible value. So I plugged in that position into the main function, and I got this minimum value of the function.
Ah, okay,
Yeah,
okay, okay.
and that
No,
is the exact value, right? I didn't decimal, like I didn't put in decimals.
so like the y doesn't matter. It
No,
is
that is
just
the y value.
yeah, this is like
Yeah.
the y.
hmm
Yeah, exactly.
It's just how they write it basically.
Yeah, okay. I got
Okay,
confused with that. Yeah.
so now for the next question, f of x needs to be less than g of x, and we want to check what the solution of this inequality is. So what I did was I put it together first, f of x is less than g of x. Okay, now the first problem I noticed in this question is that you cannot play with a bunch of natural logs if the inside of them is not the same. It's like gonna be really hard to work with them. So what I did was I realized that I have x plus 3 here and I have 1 over x plus 3 there. Why not write 1 over x plus 3 as x plus 3 to the power of negative 1? Why? Because of a very nice rule, and that is if you have something with a power on it inside of a log, you can pull that power out, right? This is a rule, this is a logarithmics rule, which means that by writing 1 over x plus 3 as x plus 3 to the power of negative 1, I can now rewrite this whole thing and pull out that negative power and put it up front using that rule, which gives me the same natural log on the left side and the right side. Is this clear?
Yeah.
Okay. Now, I guess let's just open everything up and kind of try to clean things up. So we have this is less than minus 3 natural log of x plus 3 plus x. I'll collect these guys on the right side. Or wait, maybe I shouldn't. I don't know. Let's see. Yeah, I think moving this to the right side or moving this to the left side would be nicer. I think I'll move everything to the left side actually. So I have minus 6 and then plus 3, so minus 3 basically. Because I have minus 6 and then I'll have plus 3 when I move this here.
Yeah.
Yeah.
I see.
And then also minus x is less than 0. Okay, so what do I do now is the question. How would I solve this? Maybe we should take the natural log x plus 3 common. Stuck. 2x minus 6.
If you want, I do have a mark scheme.
Yeah, you'll have to look at that.
I
So there was a little mistake. There's a plus x in the f of x that I didn't see, which means that f of x being less than g of x would look more like this. Now the good part of this is that we have a plus x on both sides of the equation, which we can cancel out. We don't like subtract x on both sides and cancel it out. The rest of the method stays the same, so 1 over x plus 3 can be written down as x plus 3 to the power of negative 1. And using this rule where we can take out a power and put it up front of a logarithm, we can rewrite that as, one second, we can rewrite this as, we can take the negative 3 and put it up front. Sorry, we can take the negative 1 and put it up front, which makes 3 negative 3. And now we have the same log on the right and the left, which means like now we can divide both sides by natural log of x plus 3 and cancel this out, which leaves us with a very nice, simple linear inequality. Add 6 to both sides, divide by 2 on both sides, and that is your answer. That's it. So this was 5 points, but I don't know why it was 5 points. It was maybe just for this one step, it's 5 points. This is, by the way, the key to solving this question, this one thing that I did here. So do you understand what happened?
Yeah.
All right. So this is the key basically. I'm just gonna circle this in a bit more gracefully. There. But I don't know why this is 5 points, honestly. It's a very, very easy question. Maybe, I don't know. Oh, oh wow. Okay. So there's a mistake again. I see why it's 5 points now. Okay. I just realized you cannot cancel out these logarithms because logarithms, you can't divide by a logarithm and cancel it out basically in these kind of cases. Let me show you why. Remember that the answer we got was x is less than 3 over 2, right? So we're only getting one answer, but let's see. So what I'll first do is I'm going to open up the left side brackets. And I'm going to like take everything to one side of the equation. So minus 6 times this plus 3 times that. So that's going to make it minus 3 times that. Now I'm going to take a natural log common. And I'm going to end up with this. Now, these are two separate factors. Originally, since I cancelled out the natural log, I only ended up with this one guy, which gave me one answer, but I'm supposed to have two answers. One for natural log of x plus 3 being less than 0, and the other for 2x minus 3 being less than 0. Now, this one is easy. X is going to be less than 3 over 2. That's the one we already got. However, for the other guy to be less than 0, oh no, wait. One mistake, sorry. God, this is a tough one. So, okay, recalibrate. This is, by the way, extremely important, something I regularly get wrong still. Whenever you see two factors being multiplied together and the multiplication is less than 0, it's not as simple as saying that each of them could be less than 0. That's not how it works. Think about it. If I tell you that two things are multiplied together,
equal.
Yeah, you have two separate cases. Either natural log is less than 0 and 2x minus 3 is more than 0, or natural log is positive and 2x minus 3 is negative. Because these are the two pairs you would need for the multiplication of both of them to be negative. They have to be opposite signs, right?
Yeah.
So we have two different cases. Let's work on each case one by one. So in this case, for this to happen, x has to be more than 3 over 2. And for this to happen, x has to be, so let's think about this. What must x plus 3 be for this to be less than 0? Let me think. It's going to be, one second. Yeah, for a natural log of something to be negative, the inside of the natural log has to be less than 1, basically. Okay. And if you want like a better explanation, then you can think about it like this. You're raising both sides to e because that's how you solve logarithmic equations, which would give you this. e to the power of 0 is 1, and that is why x plus 3 would have to be less than 1 for this thing to be negative, which means that x has to be less than negative 2. So this is one case. The other case would be that x plus 3 has to be more than 1, which means x has to be more than negative 2. And from here, x has to be less than 3 over 2. So ultimately, this case is x has to be between negative 2 and 3 over 2. And for this case, x has to be between negative 2 and 3 over 2 again, actually. Wow. Okay, both of them give you the same answer. Wait, no. Sorry. For this case, x has to be less than negative 2, or x has to be more than 3 over 2. Yeah, because you have opposites. But, no, sorry, and. Because you need both of these things to be true together. You need this to be positive and this to be negative, otherwise the whole thing cannot be negative. So you need x to be less than negative 2 and x to be more than 3 over 2 at the same time, which is impossible. So this answer doesn't count. And for this case, x has to be more than negative 2 and less than 3 over 2, which works. So you have a range now. So this is your final answer. Okay. So just to recap,
And why the first one is impossible again?
Because for x to be less than negative 2 and more than 3 over 2 at the same time, that's impossible. How could you satisfy both of those conditions together? But what I want to kind of bring your attention to, because this is the biggest takeaway from this question, is whenever you see an inequality where there's two factors and you're multiplying them and you want their multiplication to be negative or positive, whatever, think about the cases. So for two things to multiply and be negative, they have to be opposite signs. So you end up with two cases where the first one is negative and this other is positive, and the other case where the first one is positive and the other is negative. Opposite signs is the thing that matters. Okay.
Yeah.
And if this was the same thing but positive instead, if I wanted these to be positive, then the first case would be that they're both negative. The second case would be that they're both positive. So remember that inequalities in these kind of cases where you have quadratics or factors, it's not as easy as it looks. Okay. You have to break it down into logical
Factors.
cases. Yeah. And other than that, I also want to kind of clarify this idea, the fact that natural log of x plus 3 being less than 0 requires that x plus 3 has to be less than 1. Why is that true? Again, whenever you have a logarithmic equation, your method to solve it is to raise both sides to the power of e. Okay? Always. And by raising this to e, the lateral log and e cancel out here and give you just x plus 3 on the left side, and e to the power of 0 is just 1. So that means that this is equivalent to this. Okay, so remember that this is the way you can check how this is going to open up. Okay, is this clear? Does this make sense?
Yes.
Okay, so for example, if it was like natural log of x plus 3 has to be less than, I don't know, like 2x plus 4 even, or let's say natural log of 2x squared plus 4, you would still raise both sides to the power of e, cancel out the e's and the ln's, and get x plus 3 has to be less than 2x squared plus 4. Okay, so this is how you can pull out the argument inequality from a natural log inequality by just raising both sides to the power of e. Okay. So two very major learning points here. This guy, the cases thing for inequalities when they're factors, and for natural logs, how to check out, how to solve an inequality with natural logs in them. Yeah, that's basically it. So this 5-pointer, it looked super easy to me actually. But yeah, once you were done with the algebra of figuring out the inequality, the real difficult part came in. Make sure that you understand everything here. A lot of options to make a lot of small mistakes here. So all of this was probably just 1 point or maybe 2. You got 3 points for doing this stuff. So most of the points from this question were coming from this cases thing. So make sure you understand this fully. That's about it.